try to solve another Leetcode problem, prime arrangements. Let's first try to understand it. So we are giving a number n. So we're gonna check all the possible arrangement from 1 to n. So for example, n equal to 5, so we're gonna have the arrangement from 1 to 5. But we need to check that the prime numbers are at the prime indices. What does that mean? So for example, 1, 2, 5, 4, 3, for this number 2, this is a prime number. And what about the index? And we should know that it is 1 indexed. This means for here the index is 2. Yeah, and we should be careful about it, you know. And for here, this 5, the index is 3. This is also valid. For this number 3, it is a prime number and the index is 5. Yeah, so basically it means we're gonna check all those numbers from 1 to 5. We will just ignore the index, because definitely we can put it to the right index because it is 1 indexed. We just need to check from 1 to 5 how many prime numbers. We have 3 prime numbers, and then we're gonna check the permutations of 3. So it's gonna be 3 factorial. So what's left behind, there are gonna 2 numbers, which is gonna be 1 and 4, and factorial of 2. So factorial of 3 times the factorial of 2. So it's going to be 6 times 2, which is going to be 12. So we're going to return this 12. As the final result is going to be a really large number, so we're going to use a modular of 10 to the power of 9 plus 7. So let's just write it. We're going to use a mod. It's going to be 10 to the power of 9 plus 7. As we're going to use a factorial, so let's just define a factorial. Because even we didn't define it, it is okay in Python. But what about other languages? And for our number, this is a small number. Modular this number is going to be okay. But what if this number is really big? It's like if it is not 100, maybe 1,000 or 10,000. Yeah, we cannot calculate it directly. But if we have this modular, we can do that. So we're going to define a factorial function. It's going to be maybe n, and the result is going to be 1. And for I in range, yeah, let's gonna start from 2. Yeah, maybe, yeah, I think maybe 2 is okay. Maybe 2 to this number. Yeah, let's just make it to 1. 1 is better, I think. So from 1 to n plus 1, and the result gonna times this number until to n, and we can modular the mod. And finally, we're gonna return the result. Also, we need to define a prime number type. So I'm gonna use acytosis method to solve it. So I'm gonna use e prime. So for here, I'm gonna use this number, and I'm gonna prepare a primes array. It's gonna be 4 times 2 plus the 2 times n minus 1. Yeah, let's just finish writing it. I think everybody should know how to write it. So if primes I, I'm gonna use a index j. So I times I to n plus 1, and the step gonna be I. So the primes I, we're gonna set it to false, and finally we're gonna return this primes array, and from here we're gonna prepare the primes array, which is gonna be e prime. The maximum number is gonna be 100, so we're gonna use 100. Yeah. Now we prepared the e primes array. This is for this one we're gonna get an array, and inside we're gonna check which number is a prime number, and this is our factorial. Now I think it's enough for us to solve the problem. Yeah. So let's just check how many prime numbers do we have. Let's use a variable maybe x. So we're gonna use primes, but we need to check that number should be from 0 to n. We're gonna check how many prime numbers. So we're gonna count true, because we set it false and true. So we're gonna check how many true. That means how many prime numbers from the range from 1 to n. N is inclusive. Now I think it's enough for us to return the final result. it's gonna be factorial of x times factorial of n minus x modular the mod. Let me just run it if there's any typos or if something is wrong. The first one is right, it is okay, but the second one is not. Maybe I did something wrong, I don't know. Yeah, I don't know, but let me just have a check. Maybe I did something wrong. This is for e prime. Yeah, let me just print out this x. Maybe this x is wrong. Let me just check that. Yeah, this x is not 98. Definitely it is wrong, because from the numbers 1 to 100, definitely we don't have 98 prime numbers. Yeah, we don't have so many prime numbers. So definitely this is wrong. Yeah, let me just check that. Maybe let me just check the primes array. Maybe this is wrong. So this is the primes array. As we can see that it is wrong. I don't know why I did it wrong, but as you can see there are so many prime numbers, so definitely it is wrong. Yeah, you know, I set it to false, but I didn't set it actually to false. It should be primes j, so this is why it is wrong. Yeah, because I don't need to set the primes I to be a false. Definitely I need to set the primes j to false. This is how to use the algorithm. You know, sometimes I made mistakes and we have to check about it. Yeah. Now I think for the primes array maybe it is okay. As you can see, it is okay. So this is false and this is true. This is 2, this is 3, this is 5. It seems yeah, the e prime is okay for our prime number tag. So what about the others? So for here, my output is I have 50 prime numbers. Definitely it is not okay, because I should not have so many prime numbers. So this means still this is wrong, but I don't know why it is wrong. Yeah, let me just check that. Yeah, because let me think about it. If primes I, so for j, yeah, let me just check it from here. So primes dot count true. I just want to check how many prime numbers from 1 to 100. Maybe, yeah, I did a mistake. I don't know. It is 50, so definitely it is wrong. I don't believe it. So for I in range 2 to n plus 1, if primes I, for j in range I times I, primes j, I set primes j to false, and then I return primes. This is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 definitely it's gonna be false, but I still made it to true. I don't believe it. So if prime I, if I equal to 3, so from this one I'm gonna set it to false, but I didn't. Yeah, I don't know why. So for I in raised 2 to n plus 1, it primes I. So for j in raised I times I, n plus 1, and the step gonna be I. Yeah, maybe I just want to rewrite it because I don't know. Let me just rewrite it. Rewrite this method. I don't know why. So, sometimes even a typo can make a mistake. I don't know. Let me prepare the primes array. It's gonna be false times 2 plus true times n minus 1, and for I in range 2 to n plus 1 if primes I for j in range from I times I n plus 1 to I, so primes j gonna equal to false, and from here I'm gonna return primes primes array. Yeah, I don't know, maybe I did a return from here. I don't know, maybe I can make a lot of different mistakes, but let me just run it. What is wrong? The e prime. Yeah, because here I need to call for it, so the prime's gonna be e primes with 100. Now as you can see, it works. Now let me just submit it. Maybe I did a return from here. I forget about it. Yeah, now as you can see, it works. Let me just recover what I did a mistake before. Maybe I did a very silly mistake. Oh, as you can see, I did a return from here. Actually, the return should be outside, should be here. Yeah, sometimes it happens, and we have to rewrite the function again. I think it should be okay. Let me delete this one and resubmit it to chat. Yeah, let me just delete this one. Yeah, now as you can see, it works. So yeah, or you can use another way, Euler's algorithm, to solve it. Definitely, it also works. Yeah, so here for me, I'm gonna use the acytosis algorithm to solve it. Yeah, let's just wait a little bit. And the time complexity is yeah, so the time complexity is dependent on this number n. And what is this number n? It's gonna be maximum for 100. Yeah, so for here, so this is just 100, and from here this is n factorial. So for n factorial, actually the time complexity is na 100. So this is the time complexity. I think I've already submitted it. Yeah, as you can see, it works. I think that's all about it. Thanks for watching. See you next time.